Thank you everyone for joining me. Good afternoon. I'm Sonam, and I'm going to present you how to make your RAG pipeline go burr. I have been listening to this word a lot, so I thought add it here because we are extremely fast, extremely efficient generative AI pipelines. So So a little bit about me. I'm the co-author and maintainer of the library called Embed-Anything. We are also building application and agents at starlightsearch.com. I worked as a generative AI evangelist at Articulate, which spun off of Intel. That basically means I was responsible for taking products into market and discussing products or changes in the products. And I also worked as an AI researcher at Saama. That means I worked with companies like Pfizer, Novartis, and finding out big data analysis for these companies. And there are two authors of this library. One is me and one is Akshay. He's sitting over there. If you have any questions, you can reach out to any of us. Okay, so let's start. What are our presentation with the vector or embedding? So what are vectors or embeddings? Has anyone ever worked with RAG? I suppose everyone knows RAG here. Has anyone deployed in production? Okay. Have you used LangChain or those libraries, Llama Index or LangChain? Okay, all right. I'll tell you how we are different. So vectors are basically numerical representation of your unstructured data. It could be PDF, images, audio, and they all cluster together based on similarity, right? And they are used in context injection for large language model, that is RAG. They can also be used in search. It has been highly useful in recommendation systems and classical ML problems like classification, anomaly detection, etc. So it's not new. It's been used for years now, this embedding. So what is Embed-Anything? So we are highly performant, highly modular, and memory safe because we are written in Rust from the ground up, and we process ingestion, inference, indexing, all three on our platform, right? For the past 1 year, we have crossed over 300,000 downloads, over around 800 plus stars. So I would really like you guys to check out our library and check out library and thus use it in production if you could. All our developers are from these countries, and they are from Microsoft, from AWS, Tencent, etc. So we're really proud of how we expanded over past 1 year. For the past 1 year, also I was fortunate enough to collaborate with Elastic, present at Google, PyCon DE, Single Store, etc., and burning buzzwords. So now, coming to the definition of our library: ingestion, inference, and indexing in Rust. So you might be wondering what that means, like what do I have to do if it is built in Rust or Go or Python? Why do I care? Right? But so briefly, if I have to say, it will make it performant, modular, and memory safe, but I'll go deeper into each point. Why modular, right? So you could use any model on Hugging Face, present at Hugging Face. You just have to choose the architecture. You could change the vector database with one line of code. No, one word of code. You just have to change the adapter here and give your keys and stuff. And you can change the re-ranker model, because if you have worked with RAG, you must be knowing that re-ranking improves the results of RAG a lot, because you again run a model over your retrieved results, right? So all the choosing of model or the vector database or the re-ranking, everything is very modular with our library. And yes, they are the collaborators or contributors to our library, and they maintain their own adapter. So what is essential? It is wrapper. They are creating wrappers around there, and they're embedding 4 functions that is present in every vector database. So if you see any vector database that is not available here, you are welcome to make your PR. Okay. What does efficiency mean? So easy to deploy, lightweight, and reduce latency. Why I am saying easy to deploy? Because our library is based on Candle, which doesn't has any torch dependency, and thus it is much more lighter. So it is 2.3 GB lighter than other platforms. So it makes it much more easier to deploy. If you are deploying others like sentence transformer, you have to take care of this extra 2.3 GB memory, and like you are paying for it on cloud, which is not a good idea, right? What was the motivation for building this, right? So the motivation came from when we were building this local application, and the issue was CPU bound task. Every heavy CPU bound task needs a server running, right? You need to start a Celery or something, but we didn't want to do that. And also Jill was one of the things, and those people who are saying Python 3.14 doesn't have Jill, maybe we can have a conversation after this talk. So we were like, let's build it ourselves, let's see what happens. So design requirements. So first of all, we started building this local application, and then we first set our design requirements, because I think it's highly unlikely when you design a software, you just think about design before, but I think it should be a practice now. We shouldn't just build software, we should actually design software. And these are our principles while designing the application. So it should run asynchronously. I shouldn't shoot up another server. All the background tasks should run asynchronously. For that, what we needed. Okay, no need to spin off a separate server. Python-based servers are bottlenecks because of Jill. True concurrency with thread safety guarantee the compile time and CPU bound tasks. So concurrency is very much different from parallelism. So in concurrency, multiple tasks can run all together, and then they can do input output at the same time. So this concurrency and CPU bound task is 2 major things that you need to consider while designing local application. This is a very good blog written by Fast API, why you have to run a separate server for these heavy memory bound tasks or CPU bound tasks. And if you want to read on details, the link is here, right? Then there is a small memory footprint. As I told you, we are based on Candle, we are not based on sentence transformer, which again comes with its own advantages of not being dependent on torch, which makes it much more lightweight. How much lightweight? So our compiled thing is like 15 MB, which is much more lighter than PyTorch compile, which is 230 MB. Plus, if you're using a GPU, it will come with 1.8 GB CUDA dependencies. Okay, avoid tech debt. So, okay, what does it mean by tech debt? Like when you're designing software, one of the good example I can see, how many of you have heard of MCP? Yeah, so MCP are basically tool calls, right? But in MCP, what's happening, someone else is maintaining the server, someone else is doing the job for you. You are not bothered about what goes in that MCP server, but you are bothered about your tool calls. So whenever the concern becomes it is tool call. When the concern becomes someone else's, it is MCP. So that's why it exploded, because the developer do not need to take care of everything. They just need to take care of the agentic code base. So that's how our thing is also like we are just taking care of the code base and not the vector databases that are attached to it. The other vector databases that are attached to it are the one who are taking care of it. So this was, yeah. So this was the first discussion that started. Initially, we just put in roadmap that we wanted to integrate vector database, and this gentleman opened a discussion that this will only bloat your library, which, like, you know, which gave us an idea, like, he's like, really right, why do we have to care about the vector database integrations? Why don't the databases care themselves? So this was a really good discussion. You can go and check it, right? So we are avoiding tech debt by design, right? Hardware agnosticism. So one more benefit of Rust is it can be compiled anywhere, from microcontroller to like huge servers, supercomputers. So yeah. Someone was building it for mobile application, and they successfully compiled it for mobile applications as well. So another one is faster inference. So we are the fastest embedding inference platform, faster than even FastEmbed, and who does everything on ONNX inference engine. So it only measures the embedding model inference speed based on ONNX model runtime and repeated hundreds of times, and these are available on benchmarks. One more thing I wanted to add, if you have to do the whole pipeline, like ingestion and indexing as well, you will have to add it. It will kind of increase the speed as well, but we haven't measured it yet. If anyone is interested, they can go ahead and do it. Okay, talking about inference performance. So why designing application matters? Because you do not know how it's going to run in production, right? Like, so this is the pipeline. Ingestion, we handle data modes like text, images, on audio. You do not need to even worry about chunking, because we support different chunking strategies, late chunking, semantic chunking. Preprocessing is also involved. The inference, we support both Candle, ONNX. Candle, I won't go in details because we have very less time. Then indexing is vector database adapters, right? Okay, so coming to the main topic, how we are reducing it. Vector streaming. Common way to do indexing is fetch PDFs, extract text, then do chunking, embedding, and absurd. But this is taking 90% of the time, this one process. Inferencing, embedding models is the most task intensive, like, intensive task. And these stop, like, if you have to chunk one thing and it keeps, it's a time wasted, right? So what is the solution here? What we should do about, like, task being stopped? And this create memory leaks as well. So these are the different issues that are open, and memory leak is like, when you're doing an embedding, you're basically taking data into embeddings, and these embeddings keep storing in your RAM. We do not store anything on the RAM. We store directly on the vector database, which kind of reduces your memory leak as well. So these memory leak issues will never happen at Embed-Anything. So what is the solution? The solution is to create a buffer which takes chunks at once, multiple chunks at once, do the embedding, and bring the embedding back to the thread one and push it to the vector database. So this is the whole solution. This is buffering system, which is basically reducing the latency. Like, now you can imagine, like, the embedding processes keep happening and it doesn't stop after chunking, right? And yeah, so to implement it, you just need three things: the adapter, the config, and the data. So what is a text config? It has three parts: the embedding model, the splitting strategy, and the batch size. So a lot of people just come to me and ask me, what's the difference between batch size and chunk size? So chunk size is basically decided by the model, how much model can chunk text data at once. And the batch size is decided by it's a function of your hardware, how many batches it can, compute at once. So it depends on hardware. We have a document that tells you like how much you should choose, and there are very good blogs as well written if you need to configure text embed config in Embed-Anything, or if you want to know more about memory leak, that is also there. Okay, so after all this, we're creating buffering system and everything, it has been reduced. It is, I think, elastic on which we did the experimentation. So with vector streaming, it is 25% faster processing time. And yeah, so this is our community. One person dedicated entire processor crate, which makes metadata extraction and like handling much easier. Then Milvus wrote a blog about us. Then Sangeeta wrote a blog about us, how to set up your experimentation using Embed-Anything. And she found out that our clip model, which was running locally, was actually 100 times faster than the cloud service. So that was pretty cool. Then there are our contributors who are very happy that it was very easy for them to contribute to our library. And then there's Philip, who also shared some words about us. So this is how our community looks like, and this is not our job. We are doing it on our time, and would love to discuss if you want to join Discord discussion or our contributions. Okay, so I have a lot of stickers, and if you're wondering where did I get this cool sticker, you can get it from me. And we are going to we have these as our roadmap. You can check the library here as well. And this is something that we are trying to build now, that is our Lumo agent, which is a transparent, accurate, and highly performant remote agent. So you can just define the task and it can do it for you, which we are designing a hackathon. So you will get $5 credit when you sign up, and you can check it out. Like, you can see how it is different from Perplexity or any other OpenAI services. So I hope you guys check this out. And this is me on LinkedIn. You can connect with me and ask any questions related to agents or embedding models. Thank you.